Hello, welcome back to CS353 Makeup Week. Here I'm talking about memory measurements, mainly density and latency. That's where I left off last time. So the time required to fetch information from memory and the time to store information in memory is a big difference when looking at memory. Therefore, we actually have to give two different values whenever we're looking at memory, and that's why you see the read and write memory to be taken into account when you look at buying new memory, for example. That's one of the details that you can look at when you're considering memory. As far as how the memory connects to the system, it goes through a memory controller. So we're going to talk more about memory controllers in Chapter 11, especially when we get to virtual memory. But basically, all memory requests are going to go through this controller that's going to have the ability to figure out where the memory is that it's actually talking about. This is an important note because it does take extra time to go through this controller, but it's also important to note that if we have a controller, there can actually be separate areas where the physical memory is, because it can kind of say, okay, well, go over to this location or go over to that location. So the processor is going to actually be requesting from the controller, not directly from the memory. It'll then wait for the response from the memory and then actually get the results from memory. So the translator, or the controller rather, is going to translate the request into signals for the actual memory chips, and then it returns the answer to the processor. So memory controllers might need extra time between operations to reset the physical memory due to DRAM. Therefore, latency is not really a great measure of performance. Latency or performance measures need to basically measure the time required for one operation after another operation. Because, remember that the refresh operation is needed. Therefore, who knows how long that refresh operation is going to take, so we want to know how much time it takes from one operation to happen and then the second operation to happen, and that'll give us an overall picture of the memory performance. So this is what we call memory cycle time. These are time elapsed between successive memory operations. This is more accurate than latency, and there's two separate measures. One is for read and one is for write. So we call this read cycle time and write cycle time. And this will tell us how quickly the memory system can handle successive requests. So memory needs to be synchronized because basically we need to make sure that we're in sync with the clock. That way we can work together with the controller to get our requests. So the memory and the processor both use a clock, and we need to be synced up to that clock. We need to use the same hardware clock. This way we can avoid any unnecessary delays while we're waiting for the next clock cycle, for example. We can also use this technology with SRAM or DRAM. There's two different terminologies that are associated with this, which is synchronized dynamic random access memory and synchronized static random access memory, SSRAM. Synchronization is effective, and many computers now use SDRAM as the primary technology behind it. Even if you're looking at DDR SDRAM or something like that, they're still using the same concepts that we've talked about here with the synchronization. So multiple data rate memory technologies are a technique that is employed to improve memory performance. As memory is often the bottleneck. Speeding up memory is going to increase the overall performance of a computer. So an approach that's used to that is to use a technique that runs the memory system as a multiple of the clock rate. So technologies here are called the fast data rate, double data, quadruple data, that kind of thing. So quadruple data, that being quad data rate SRAM. So it's a multiple of the CPU clock. Here's some examples of that memory. Everything from double data rate dynamic RAM, DDR DRAM, up to reduced latency dynamic RAM. All various configurations of how the memory is synced up with the clock. So memory organization is basically set to have a parallel interface between the computer and the memory. We're going to talk about the bus idea later in the book, in the chapter that is. But for now, all that's important is to understand that there is a bus that goes between the controller and the processor, and that it's effective and can effectively give us our requests from the processor to the transfer to the memory system.